cube, and the volume of the acid is equals to 250 cm cube. If 1000 cm cube of hydrochloric acid is equivalent to 0.5 molarity, therefore 250 cm cube of hydrochloric acid is equivalent to 0.5 over 1000 times 250 over 1, which will give us 0.125 molarity. But from the equation, 2 moles of hydrochloric acid is equivalent to 1 mole or 24 grams of magnesium. Therefore, 0.125 mole of hydrochloric is equals to 224 over 2 times 0.125 over 1, which is equals to 1.5 gram. Question 8. A gaseous metallic chloride MCl consists of 20.22% of M by mass. The formula of the chloride is solution. A metallic chloride which can exist in gaseous form is aluminum chloride, AlCH3, which sublimes. The metallic chloride MCl contains 20.22% M, and the atomic mass of M is 27. Therefore, 20.22% of MCl is equals to 27. MCLS is equals to 27 plus 35.5x. That is 20.22 over 100 times MCLX over 1 is equals to 27. That is MCLS is equals to 27 over 1 times 100 over 20.22, which is equals to 133.53 gram. That is 27 plus 35.5x is equals to 133.5. 35.5s is equals to 133.5 minus 27, which is equals to 106.5. Therefore, x is equals to 106.5 over 35.5, which will give us 3. Therefore, MCLX is equals to MCL3. Question 9. In which of the following are water molecules in most disorderly arrangement? A. Ice at minus 10. B. Ice at 0 degrees Celsius. C. Water at 100 degrees Celsius. D. Steam at 100 degrees Celsius. Solution. Entropy is the degree of randomness or disorderliness. In solid sample, example ice, the particles are orderly arranged and closely packed, hence strongly held together by attractive force. In liquid sample, example, water molecules are loosely packed and held together, hence not quite orderly arranged. In gaseous sample, example steam, the molecules are in constant random motion, hence not orderly arranged. Gaseous particles have the highest degree of entropy or disorderliness particle which when heated. So therefore the answer is D. Question 10. In order to remove one electron from a 3s orbital of gaseous sodium atom, about 496 kJ per mole of energy is required. This energy is referred to as A. Electron affinity, B. Ionization energy, C. Activation energy, D. Electronegativity. Solution. Ionization energy is the energy required to knock off or remove 1 mole of electrons from a mole of atom in gaseous state. Therefore, answer is D. Question 11. Nitrogen obtained from the liquefaction of air has a higher density than the obtained from nitrogen-containing compound because the former contains A. Water vapor, B. Oxygen, C. Carbon dioxide, D. Rare gases. Solution. Nitrogen is obtained from the liquefaction of air, contains the noble gases as impurity, which increases their mass, hence the density of the nitrogen gas. Whereas nitrogen produced from nitrogen containing compounds like ammonium diosonitrate contains no other substance impurity other than nitrogen, hence has lower density. Answer D. Question 12. The method can be used to convert hard water to soft water is A. Chlorination, B. Passage over active charcoal, C. The use of an ion exchange resin, D. Aeration. Solution. Method of softening hard water includes boiling, addition of calculated amount of slick lime, CaOH2, addition of washing soda, permitted method, addition of zeolite, and by use of cation exchange resin. Answer is C. Question 13. The element that is likely to participate in covalent rather than ionic bending is A, Z, B, Y, C, S, D, W. Solution. Elements of group 1, 2, and 3 in the periodic table of elements are electropositive metals which can only undergo chemical bonding by electron transfer. Elements of group 5, 6, and 7 are electronegative nonmetals which can only gain electrons. Thus, they can accept electron transfer by the metals in electrovalent bonding. They can as well contribute electrons from sharing covalency. The elements in group 4 do not accept electrons but can only contribute electrons for sharing covalent bond. Answer is C. Question 14. The least reactive element is A, W, B, X, C, Y, D, Z. Solution. The elements in group 0 have their outermost shell filled up. Hence, zero valency, they are very unreactive inerts. Answer D. Question 15. 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. An element with the electron configuration above is A, non-metal, B, metal, C, transition element, D, group element. Solution. The transition element metal are the elements in which the 3d orbitals begin to fill up. Thus, the composition or fill up of the two shells at a time. The electron configuration 1s2, 2s2, 2p6, 3s2, 2p6, 3d7, 4s shows that the 3d orbital is being filled up. Hence, the element is a transition element. Answer C. Question 6.